Well, dear students, in today's class also we will continue to discuss the CET questions on the chapter potential and capacitance. So, we have started discussing few questions. Now, the next question I am going to discuss is the question number 30, wherein a hollow conducting sphere is placed in electric field produced by the point charge placed at P as shown in figure. VA, VB is VC, that potential at A and B and C respectively anta ide. So here is question number 30. If you refer, here is arrangement shown. This is point P shown. Here are the points B, like A, something like C are shown. If you observe carefully, A, B, C. This is of course B, and this is C. Now asking for potentials at A, B and C. As for the options, you will see that potential at C greater than B given, potential at A greater than B given, potential at B greater than C given, potential VA is equal to VC given, and you observe carefully, potential at all points on this surface is same. Therefore, in fact, VA is equal to VB is equal to VC. Potential at all points on the surface is constant. Though electric field inside is 0, but potential will be same due to the charge. So hence, this is the result you find. Accordingly, one of the option given as VA is equal to VC. Coming to question number 33, there is an arrangement given 5, 0, 0 given, minus 5, 0, 0 given in centimeter. Two charges at these two positions are given, 4 microcoulomb and minus 3 microcoulomb. Remember, this is how it is given. This is arrangement given. Now, what is the question? Question is amount of work required to separate the two charges infinitely away from each other. The question is work required to separate two infinite distance. Now, what is the potential energy for this position if you refer? Right? What is the potential energy for this position? And when the charges are moved away to infinite distance, then potential energy between them will be 0. Now at this position, work done is equal to potential for this position, that is 1 by 4 pi E naught into Q1 Q2 divided by distance. When they are taken to infinity, it is 0. When they are separated by infinite distance, it is 0. The work done is potential energy here minus potential energy at infinity. Therefore, you will find work done is equal to, this is 9 into 10 to the power 9, Q1, Q2 minus 3 and 4 microcoulomb 10 to the power minus 12. Look at the distance. This is origin. 5 centimeter here, 5 centimeter, total distance will be 10 centimeter between them. So it is 10 centimeter, 10 into 10 to the power minus 2. This is what you have to simplify. 3 4s are 12, 12 9s are 108 with minus sign into 10 to the power. Look at this, minus 3 plus 1 minus 2. This is minus 1.08 joule. According to the given options, it is nearly minus 1.1 joule, friends. The two charges minus 3 microcoulomb and 4 microcoulomb separated by distance. So one is at 5 centimeter on the positive x-axis, one is at minus 5 centimeter on the negative x-axis. So distance will be 10 centimeter. So now at this position for this arrangement, they have some potential energy, and when they are taken to infinite distance, they have some other potential energy. Next, question number 35, students. Quark model of elementary particles neutron made up of one up quark and two down quarks. A triangular configuration with this length of the order of 10 power minus 15 meter. This is what given the arrangement looks like this. This is what the arrangement. So this is what we call neutron is made up of. A neutron has zero charge. It is found that according to Quark model of elementary particles, neutron is made up of three fundamental particles. This is called up quark. These are two down quarks. Now if you add total charge, it will be 2 by 3e minus 1 by 3e minus 1 by 3e. This is equal to 0. Hence neutron has zero charge and it is made up of one up quark, two down quarks. Now what is the electrostatic potential energy of system of these three charges? The question is electrostatic potential energy of system of these three charges. Here is the answer. U is equal to, general formula I write students, 1 by 4 pi E naught into Q1 Q2 divided by distance D1 to R12 you can write, plus Q2 Q3 divided by R23 plus Q3 Q1 divided by R31. This is how. However, R12 is equal to R23 is equal to R31. Look at this, it is same. 10 power minus 15 meter given. 10 to the power minus 15 meter given. And Q1, this is Q1, this is Q2, this is Q3. Therefore, this is 9 into 10 to the power 9 divided by, this is 10 to the power minus 15 into Q1, Q2, 2 by 3 and 1 by 3. 2 by 3 into minus 1 by 3e plus minus 1 by 3e and minus 1 by 3e becomes plus 1 by 3e into 1 by 3e. Here is e into e plus this is again 2 by 1 by 3 with the minus sign e into 2 by 3e. This on simplification 9 into 10 to the power 9 plus 15 24. E square is common, minus 2 by 9 plus 1 by 9 minus 2 by 9. Look at that, the answers are given in MeV, mega electron volt. So you have to divide by 1.6 in 10 power minus 19 to get in AeV first. E is the value 1.6 in 10 power minus 19 into this is minus 4 by 9 plus 1 by 9. This is 9 into 10 to the power 24 into, this is 9, this is minus 3. So this cancel. Minus 3 into 10 to the power 24 into one more e is there here, see that, into 1.6 into 10 to the power minus 19 because this e square 1 e. 16 3 is 48 minus 4.8 into 10 to the power 24 ಅಲ್ಲಿ ಮತ್ತೆ 19 ಹೋದರೆ it will be 5 or this is minus 0.48. This is EV, electron volt answer, in 10 to the power 6 EV minus 0.48 MeV students, mega electron volt. Observe the calculation carefully. Answer is minus 0.48 mega electron volt. As we know that students, we are referring to some important selective questions. So next we'll go with question number 44. Here is an arrangement. One conducting sphere of radius A given connected to another conducting sphere of radius B. Now the question is what is the ratio of electric field on conductor A and B? Well students, one thing is very clear: when two charged conducting spheres are connected by means of a wire, as you know that charges will flow from one conductor of higher potential to another conductor of lower potential. And you know how long it will flow? Until the potentials of both are same. Right? And remember, this idea is same as heat flows from one body at a higher temperature to one body at a lower temperature until the temperatures are same. So let us consider assume that charges will flow from conductor A to conductor B. Charge on this is say Q1, charge on this is say Q2. Then we can write when common potential is attained, common potential attained, you will find V1 is equal to V2. This is K into Q1 by A is equal to K into Q2 by B. Q1 by Q2 is equal to A by B. Now you can take the ratio of electric field. You will come to know the result. The ratio of charges we came to know, because to calculate ratio of electric field we need ratio of charge. So ratio of charge we came to know it is A by B. Therefore, now if you go apply ratio of electric field, EA by EB, general formula is K into Q1 by A square divided by K into Q2 by B square. With this cancel, and what is Q1 by Q2? That is A by B. Q1 by Q2 into B square by A square. What is Q1 by Q2? A by B into B square by A square. This will become B by A. Answer is B by A, students, because whenever an arrangement of this kind, charges will flow until potentials are same. So after attaining common potential, so you will see that ratio of charges becomes ratio of their radii. Larger the radius, more the charge. Smaller the radius, less the charge on the surface of the conductor. Well students, I shall also consider one question. I forget, before itself I should have considered. This question number 18. Accordingly, two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb located 40 centimeter apart. The potential at the midpoint of the line joining 0.8 and 2.8, midpoint of the line joining. Midpoint becomes 20 centimeter. So potential here is potential due to first charge and potential due to second charge. It will be 9 into 10 to the power 9 common. Remember, distance is 20 centimeter, 20 in 10 power minus 2 to 1.8 plus 2.8 microcoulomb, 10 power minus 6. 18th question. Potential due to two charges. So 9 into 10 to the power 9 divided by 0.2, 1.8 plus 2.8. This becomes 4.6. 10 to the power minus 6. This is the answer. This is 9 into 4.6 into 10 to the power 3, 10 to the power 4, 2. 2.3 times. Or as per the given answer, it will be 2.07 into 10 to the power 5 volt. Or it is almost 2.1 into 10 to the power 5 volt. So I took the previous question, 18th question, where potential due to two charges at the midpoint is calculated. Well students, question number 19, if you observe, that is followed with question number 18. They are asking for the same two charges, they are asking for potential at a point 20 centimeter from the midpoint of line joining the two charges in a plane normal to the line and passing through the midpoint. Like on the equatorial line, they are asking for electric potential for the same arrangement. This is 1.8. This is also given 20 centimeter. If you call this is A, this is B, then this distance, so this distance, look at this is a right angle triangle, AOP and BOP are right angled triangles. Therefore AP is equal to square root of AO square plus OP square. This is even same as students BP. So this 20 and 20 and it becomes 20 root 2 students. Remember 20 root 2 centimeter. This is very clear. So along the plane normal to the line, this is the plane normal to the line. In fact, this is the point 20 centimeter from the midpoint of the line joining of charges. You read the question carefully, you will see that in the question number 18, the potential at a point 20 centimeter from the midpoint of the line joining the two charges in a plane normal to the line, and passing through the midpoint, normal to this line of line joining, normal to this line. So AP distance is equal to BP distance is equal to 20 root 2 centimeter. Therefore potential at P is equal to potential due to charge at A plus potential due to charge at B. This is I take 9 into 10 power 9 divided by the distance 20 root 2 into 10 to the power minus 2. Because it is in centimeter, into this is 1.8 plus 2.8 into 10 to the power minus 6. This is the answer, friends. This one you have to simplify. It nearly comes out to be 1.4 into 10 to the power 5 volt. You can verify the calculations, the result. Next, if you refer question number 20. Four charges at the four corners of a square given. Yes. Of side A given. And there is a charge minus q at the center. Question is work done in carrying the charge minus q from center to infinity. The question is, what is the work done in carrying this charge minus q at the center? From here it should be carried to where, to the infinite distance. So work done is equal to potential difference at O minus potential difference at infinity into the charge supposed to be moved. Of course it is minus. This is the general formula. Work done is equal to potential difference between 2 points between which the charge is supposed to move into that charge which is to be moved. And we know very well potential at infinity is 0. Either may be due to single charge or due to many charges. V infinity is 0, students. Therefore, V at O will be potential at O due to 4 charges at the 4 corners. And this is distance. This distance you have to find. This will be, you remember, this diagonal will be root 2a. Yes. And this is half of that. A by root 2. This is a by root 2. This is a by root 2. I hope you understand this, students. Distance from the corner to the center of the square of side A will be a by root 2. This is 1 by 4 pi e naught. And all the 4 charges are identical. Hence 4q divided by distance a by root 2. This is simple. Now therefore work done. Therefore work done, you see that. V at O minus V at infinity 0 into the charge which is to be moved minus q, which is 1 by 4 pi e naught 4q divided by a by root 2 into minus q. This is 0. This and this cancel, students. Root 2 goes to numerator. Q and q square. We will be left with minus root 2 q square divided by pi e naught into a. This is the work done. And considering magnitude, you can put avoid minus sign also. This even can be studied as V infinity minus VO. I referred because potential, higher potential to lower potential charge moves. So hence I took VO minus V infinity. If you take V infinity minus VO, then you will get obviously plus sign. Otherwise minus sign we got considering work done amount, and then you can avoid minus sign also. Next, let us refer questions on capacitors, some questions on capacitance and capacitor. And you remember, students, so we have discussed even various concepts on capacitors, and even I discussed the diagrams of capacitors, calculating effective capacitance. So many structures were also taken to calculate effective capacitance. How it is simplified ಅನ್ನೋದೆಲ್ಲ ನೋಡಿದ್ದೇವೆ. And even some calculations of potential ratio, charge ratio sums ಕೂಡ ಸಾಕಷ್ಟು ಮಾಡಿದ್ದೇವೆ. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ನಾನು ತಗೊಳ್ತೇನೆ. ಇನ್ಫ್ಯಾಕ್ಟ್ ಕೆಪಾಸಿಟರ್ಸ್ ಮೇಲೆ ನಾನು ಸಾಕಷ್ಟು CT ರಿಲೇಟೆಡ್ ಕ್ವಶನ್ಸು ಇದನ್ನು ಕ್ಲಾಸಲ್ಲಿ ಅಂದರೆ ರೆಗ್ಯುಲರ್ ಕರಿಕ್ಯುಲಮ್ ಹೇಳಬೇಕಾದ್ರೇ ಅಲ್ಲಿ ನಾನು ಕ್ವಶನ್ಸ್ ತೊಗೊಂಡು ನಿಮಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇನೆ, ನೆನ್ಪು ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸು ನಾನು ನಿಮಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೇನೆ. ಕ್ವಶನ್ ನಂಬರ್ 62 ನೋಡಿ, ಕೆಪಾಸಿಟರ್ಸ್ ಮೇಲೆ ಏನಿದೆ ಕ್ವಶನ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಎ ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಕೆಪಾಸಿಟರ್ ಆಫ್ ಕೆಪಾಸಿಟೆನ್ಸ್ 5 microfarad and plate separation 6 centimeter is connected to a 1 volt battery and charged. A dielectric of dielectric constant 4 and the thickness 4 centimeter is introduced between the plates of the capacitor. The additional charge that flows into the capacitor. When a dielectric slab of certain thickness is placed between the plates of the capacitor, the new capacitance is given by the formula. Original capacitance is given, students, with air as dielectric. Original capacitance is given 5 microfarad originally, when air is the dielectric. Now when a dielectric of certain constant, then you have the formula, if you remember, d minus t plus t by k. This is the general formula you have to know. D minus t plus t by k. Here t is the thickness, d is the distance, k is the dielectric constant, right? Distance between the plates of the capacitor is given 6 centimeter. Distance between the plates of the capacitor is given 6 centimeter. Now some portion is occupied. This has dielectric constant K. This is T. Remaining is D minus T. Here I take T as common, D common. It will be 1 minus T by D plus T by dk. Why? Because so that I write this as C. Refer this. And T D values you can substitute. So this becomes equal to C dash is equal to C divided by 1 minus T by D plus T by dk, D into K. C given 5 microfarad, T given 4 centimeter, D given 6 centimeter, and K is also given, dielectric constant value given 4. This is given 4. Substitute the values. Substituting in the above. Continuing question number 62, C dash is equal to C divided by, you remember, 1 minus T by D plus T by D into K. You are left with now. Substituting, this is given 5 microfarad divided by 1 minus 4 centimeter by 6 centimeter plus 4 centimeter by 6 centimeter into, this is also given 4. This is 5 divided by, remember, 4 and 4 cancel. Therefore, 1 minus 4 by 6 plus 1 by 6. 6 minus 4 plus 1 divided by 6. 6 goes to numerator. It is being LCM. 30 divided by 2 plus 1, 3. Remember, this is a 10 microfarad. Now, therefore, the additional charge, because of increase in capacitance, Q dash is equal to C dash into the potential being connected, which is 10 microfarad into 1 volt being connected is equal to 10 microcoulomb. Is the answer. 62nd question, friends. 10 microcoulomb. From here it is how it is simplified. You should remember this formula, very important. In fact, we have worked out, refer them discussion made earlier, we have worked out how to reach this result. When a dielectric slab of dielectric constant K and a certain thickness when placed between the plates of the capacitor, what is the new capacitance? We have worked out and arrived at this result. And you remember, for a conducting slab, the formula is just d minus t. For a conducting slab, E naught A by d minus t. Because K is infinity for a conducting slab, therefore this becomes a 0. Well, students, 63rd question also follows on the same, where distance is 3/4 of d. The change in the capacitance when the slab is inserted between the plates. The new capacitance. Distance between the plates is d and thickness is 3/4 of d. For the same arrangement, suppose if thickness is given 3/4 of d and dielectric constant K between the plates, using the same formula, because t is 3/4 d. So d minus 3/4 d is 1/4 plus now 3d by 4k. d by 4, if you take common, 1 plus 1 by k, 3. And according to the answers, if you simplify, students, according to the answers, if you simplify, according to the given answers, of course this is also one of the answer. If you want to simplify according to the answers, so you can take this is C, so remaining we can calculate. And taking this 4 inside, 1/4 plus 3/4k. This is even same as, friends, this is what the answer said. This is rewritten into this fashion. Or you can write 4k to the numerator. Want to get according to the given result, you can refer question number 69. Minimum number of capacitors, each of 8 microfarad and 250 volt, used to make a composite capacitor of capacitance 16 microfarad. Right. Minimum number of capacitors required. Minimum number we require. each of 8 microfarad and their PD and of PD 250 volt to get a total of 16 microfarad of PD 1000 volt. This is the question. One thing is very clear, 1000 volt total, each one 250 first. If you divide 1000 by 250, you will get 4. Andre 250 volt, 250 volt, 250 volt, 250 volt ಇರಬೇಕು. ಅಂದರೆ ಒಂದು ರೋನಲ್ಲಿ 4 ಕೆಪಾಸಿಟರ್ಸ್ ಇರಬೇಕು. ದಿಸ್ ಇಸ್ ವೆರಿ ಕ್ಲಿಯರ್. ಒಂದು ರೋನಲ್ಲಿ 4 ಕೆಪಾಸಿಟರ್ಸ್. ಯಾವ ಥರ? This is what? Like 250, 250, 250, 250 will become 1000. Like this we need many rows. Balast rows ಬೇಕಿದ್ದಾರೆ. And so on. ಎಷ್ಟು ರೋಸ್ ಬೇಕು, ಯು ಹ್ಯಾವ್ ಟು ಚೆಕ್. ಸೊ ಒಂದು ರೋನಲ್ಲಿ 4 ಕೆಪಾಸಿಟರ್ಸ್ ಕೊಡಬೇಕು. ಸೊ ದಟ್ 250 ವೋಲ್ಟ್, 250 ವೋಲ್ಟ್, 250, 1000, ಇದು 1000, 1000, 1000, 1000 ಈ ಥರ ಎಷ್ಟಿರಬೇಕು. ಸೊ ಒಟ್ಟು 16 ಮೈಕ್ರೋಫ್ಯಾರಡ್ ಬರಬೇಕು. ಹಾಗಾದರೆ ಫಸ್ಟ್ ಈ ರೋನಲ್ಲಿ ಎಷ್ಟು ಗೊತ್ತಾ, 4 ಕೆಪಾಸಿಟರ್ಸ್. ಅದರ ಎಫೆಕ್ಟಿವ್ ಬಂದ್ಬಿಟ್ಟು ವಾಟ್ ಈಸ್ ಎಫೆಕ್ಟಿವ್ ಆಫ್ ದಿಸ್, C/8/4 2 ಈ ಥರ ಎಷ್ಟಿದ್ರೆ 16 ಮೈಕ್ರೋಫ್ಯಾರಡ್ ಆಗುತ್ತೆ. 8 ರೋಸ್ ಇದ್ರೆ ಆಗುತ್ತೆ. 8 ರೋಸ್ ಇರಬೇಕು. ಎಫೆಕ್ಟಿವ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಇನ್ ಈಚ್ ರೋ ಇಫ್ ಯು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಎಫೆಕ್ಟಿವ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಇನ್ ಈಚ್ ರೋ to of each row C/4 which is equal to 8 microfarad by 4 which is equal to C in a row 2 microfarad. And what total capacitance required? 16 microfarad. So number of rows, to get total composite capacitance of 16 microfarad. Number of rows are 8 and in each row how many capacitors? 4. Therefore total number of capacitors 8 into 4, n is 8 and in each row 4 capacitors, 8 such rows. Therefore total number of capacitors capital N is equal to n into 4, 8 into 4. This is equal to 32 capacitors you require. Total 32 ಬೇಕು. 32 capacitors ಯಾವ ಥರ ಇರಬೇಕು, ಪ್ರತಿ ರೋನಲ್ಲೂ 4 capacitors ಇರಬೇಕು. ಆ ಥರ ಎಷ್ಟು ರೋಸ್ ಇರಬೇಕು? 8 ರೋಸ್ ಇರಬೇಕು. ಸೊ ಒಟ್ಟು 4 8 32. ಪ್ರತಿ ರೋನ ಎಫೆಕ್ಟಿವ್ ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟು 2 ಮೈಕ್ರೋಫ್ಯಾರಡ್. ಯಾಕೆಂದರೆ ಒಂದು ರೋನಲ್ಲಿ 4 ಕೆಪಾಸಿಟರ್ಸ್ ಇದೆ, ಪ್ರತಿ ಕೆಪಾಸಿಟರ್ ವ್ಯಾಲ್ಯೂ 8 ಮೈಕ್ರೋಫ್ಯಾರಡ್ ಇದೆ. ಸೀರೀಸ್ ಕಾಂಬಿನೇಷನ್ ಐಡೆಂಟಿಕಲ್ ಇದ್ದರೆ ನಾವೇನು ಮಾಡ್ತೀವಿ, C/4 ಮಾಡ್ತೇವೆ. 8/4 2 ಆ ಥರ 8 2 × 8 60. ಇನ್ನು ಒಂದೆರಡು ಕ್ವೆಶನ್ಸ್ ತೊಗೊಳ್ತೇನೆ ಸ್ಟೂಡೆಂಟ್ಸ್. ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 76. ಏನಪ್ಪ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 76 ಅಂತ ಹೇಳಿದರೆ, a parallel plate capacitor, air capacitor has a capacitance C. When off, filled with a dielectric constant 5, the percentage increase in the capacitance will be. This is question number 76. ನೋಡಿ, ಒಂದು ಪರ್ಸೆಂಟೇಜ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮೇಲಿದೆ ಕ್ವೆಶನು. ಒಂದು ಅರ್ಧ ಪಾರ್ಟು ಅಂದರೆ D/2, K = 5. ಇದೆಲ್ಲ ಏರ್, ಇನ್ನೂ D/2 ಏರೇ ಇರುತ್ತೆ. Well, referring this question, half part is filled with K = 5, remaining half with air. Then we have formula C dash is equal to E naught A by D minus T plus T by K. This C dash is equal to E naught A by D minus D by 2 plus D by 2K, and K value given 5. D/2 plus D/2K, ಇದು D/2. E naught A by, ಇಲ್ಲಿ 2K LCM 2K ಮೇಲಕ್ಕೆ ಹೋಗುತ್ತೆ, ರೈಟ್. ಇಲ್ಲಿ K+2 ಉಳಿಯುತ್ತೆ, K+1 ಉಳಿಯುತ್ತೆ. ಇನ್ಫ್ಯಾಕ್ಟ್ ಇದು D ಹಾಗೆ ಇರುತ್ತೆ. ಇದಿಷ್ಟು C, 2 × 5 10/6 5/3. C dash is equal to E naught A by D is to C into 2 × 5 divided by 5 plus 1, C into 10 divided by 6, ಅಥವಾ 5C/3 ಆಗುತ್ತೆ. ಪರ್ಸೆಂಟೇಜ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಬೇಕು ಅಂದರೆ 5/3, C dash by C -1 into 100 ಮಾಡಬೇಕು. ಪರ್ಸೆಂಟೇಜ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಗೆ 5/3 -1 into 100 ಮಾಡಬೇಕು. ಇದು ಬಂದ್ಬಿಟ್ಟು 5/3 -1 2/3, 2/3 of 100, ನಿಯರ್ಲಿ 66.6% ಬರುತ್ತೆ. ಇನ್ನೊಂದು ಕ್ವಶನ್ ನೋಡ್ಕೊಳ್ಳಿ, ಕ್ವಶನ್ ನಂಬರ್ 84. Capacitance of spherical conductor of radius given, 18 centimeter, and charge given. What is energy of the charged conductor ಕೊಟ್ಟಿದ್ದಾರೆ. C is equal to 4 pi E naught R. Isolated spherical conductor, radius 18 centimeter given. Two into 10 to the power minus 11 farad. minus 2 minus 9. Then charge on it is given 5 in 10 power minus 6. Therefore energy stored can use directly formula q square by 2c. Q given 5 in 10 power minus 6, 2 into C is again 2 into 10 to the power minus 11. This is 5 by 4 and this is square, sorry. This is 25 by 4 minus 12 minus 11 10 to the power minus 1. Nearly this is 0.6 joule. Why? Because 4 6 is 24. 2.5 by 4. Nearly 0.6 joule. Well students, we have considered some important selective CET questions from the material provided to you. So with this we conclude the session, and I will be also providing you a synopsis part of CET to read yourself on the groups, and even some assignment for CET part you can work out at home, okay? And in the next session we will go with the next chapter, that is current electricity.